Hello again, Frank Delatorre with RTCA DO254 lessons here. Reality demystified. DO254 demystified, that is, and the reality of how this all works. Alright, so we've come to the point where we're going to wrap up this introduction of my series. I'm going to wrap it up by talking a little bit about what really happens again. What typically happens is we end up reverse engineering a lot of or everything that's been designed, right? Because as I said before, you have a development team, a company that wants to jump right in and start doing the design, and you even have a customer that is pushing you to do it. And there is no pushback to say, give us time, let us review your system requirements, let us break it down, let us decompose your requirements, create our own, create an architecture, create performance and functional requirements. That doesn't happen. So what you end up doing is going in and reverse engineering all the design as it currently exists, and it takes a lot of manpower and effort when it's done correctly. When it's done incorrectly, this means that all of the implementation details are used and they're thrown into doors and they're presented as quote unquote our requirements. This is another mistake. Please don't do that. What you end up doing then is verifying the design. You're not supposed to verify the design. You're supposed to verify the design against the functional and performance-based requirements. In other words, if there's a problem with the design and you have used the implementation details of the design to test the design, you're never going to find any problems. That's pretty straightforward. Alright. Now, this is a pretty rigorous process. It takes somebody with experience to go in and review all of the design data, all of it. And that person needs to have the experience and the talent to ferret out all of the function and the performance out of the design without speaking to any of the implementation detail. And it's a hard thing to do. Most designers have a hard time separating themselves from the implementation detail and traversing up to a little higher level and thinking about just the functionality. Everybody wants to think about how I did it rather than what it does. There's a big difference if you think about that. How I did it versus what it does. Alright, so and in so doing of the reverse engineering, you have to have coverage for the requirements. So in other words, you have code and you have requirements. Code cannot exist without requirements, and requirements cannot exist without code. Reason being is if you have code and no requirements to match that code, then code shouldn't exist. If you have requirements and no code, then you've overlooked functionality. What this is trying to do when you reverse engineer for functionality and performance, you are trying to make sure that there is no intended function or performance that exists that shouldn't exist. That is the whole point of making sure there's code coverage and requirements coverage and back and forth. Alright, so what happens is you end up creating what is called an HRD in some places, a hardware requirements document, or an HRS, a hardware requirement specification. And so let's say for the Boeing 787, There were several HRSs, one for the FPGA, each FPGA, one for each board in the box, and one for the box itself. And so these were all stored in doors, all of these HRSs. And within doors, we were able to trace between the tiers so that you could tell what was derived, what was allocated as far as requirements. So you have derived requirements, allocated requirements, and if they're derived, you have derived justification. In other words, speak to the technical reasoning as to why some particular design function exists. Why does that need to exist at the FPGA level? Why was that decision made to include that counter or whatever? These are the details. I'll get into more of those details later on in the series. Alright, so that's the reality of reverse engineering a design after it's done or a long way into the life cycle process. Alright, now what I'm going to do is I'm going to cover these other topics. I'll break them down and spend more time on them. Again, this is where the rubber meets the road. In my opinion, the RTCA D0254 Design Guidance Assurance book, manual, whatever it's called, is really high level. So this is more of what I've seen, what I've experienced over the years at several different companies from coast to coast. So what we'll do is we'll talk about V&V. What is it? Why it's important? What is an SOI? What are they? There's 4 of them. SOI 1, 2, 3, and 4. What are their importance and what happens in each one? And which one is the most important? What is CM? What is configuration management? What its role is and why it's important? And what are requirements? What's the role of requirements and how important requirements are? You will be surprised. Alright, so that wraps up our introduction before I get into all of this, which is the meat of the entire process. Alright, again, my email, website, and phone number. Again, thank you for your time, and please subscribe to my channel.